Okay, so in this slide we shall take a look on this modulus function and how to draw the graph of this function, and from there we shall check the continuity and differentiability of this given function from graph. So first we will try to draw the graph of this function. Now before drawing the graph of this function, we must take a look whether this given function is odd or even, and for that we need to place a check on this given function. First I shall replace x with minus x with a negative input. And what we are getting is that mod of minus x will be equivalent to mod of x. So this tells me that f of x is equivalent to f of minus x. So this given function is an even function. That means the graph of this function would be symmetrical about y-axis. Now this check is done so that we can draw the graph with ease. Okay, and one of the best practice in drawing an even function is that we should first draw the graph for the positive value of x. So let x be greater than 0. First we shall draw the graph of this part, and then we shall take the mirror image of that part of the graph about y-axis to complete the graph. So we have for x greater than 0, f of x would be x. Mod will open with a positive sign when x is greater than 0 for x greater than 0. Now this is nothing but a straight line y equals to x, since fx is y. So this is the equation of a straight line y equals to x when x is positive. So we shall draw the equation of this line y equals to x for positive values of x. Okay, making an angle of 45 degree. Let this line be OA. Let this line be OA, and which makes an angle of 45 degree. With x prime OX, with a positive direction of x-axis, it makes an angle of 45 degree. Now as this graph is an even function, we shall take the mirror image of this part about y-axis. Therefore it would look like this. Okay. It would be like this. Okay, so this angle is this line OB makes an angle of 45 degree with OX prime. Okay, but this angle, if we consider the angle from the positive direction of x-axis, then it would be 135 degree. This is 135 degree. So this is the graph of our modulus function. The bottom line is that when the function is an even function, we shall draw the graph of the function for positive values of x, and then we should take the mirror image of that part about y-axis to complete the graph. And from the graph we could see that the domain of this function is the set of all real values, or we could see it is from minus infinity to infinity. As we can see it graphically too, if we take a shadow of this graph on the x-axis, we could see that the domain is the set of all real values from minus infinity to infinity. Whereas if we take a shadow of the graph on the y-axis, we can see that the graph always accepts non-negative values. So the range of the function is 0 less than equal to y less than infinity. So this is the range of the function from 0 to infinity, this part. From 0 to infinity onwards, like this. So this is the range of the function. Now as we can see, this graph is we could see the smoothness of this graph throughout in its domain. From minus infinity to infinity, we could feel the smoothness of this graph. There is no break or hole in the graph. Therefore, this graph is continuous throughout its domain. It's continuous everywhere, and definitely it is continuous at x equals to 0. But at x equals to 0, we could see at x equals to 0, we could see that at x equals to 0 there is a sharp corner. Definitely there is a sharp corner. So we could say that at x equals to 0, the function is non-differentiable. This function is non-differentiable at x equals to 0 as there is a sharp corner. So by drawing the graph of this function, we could find the domain, range, continuity, and we could also see where the graph is non-differentiable. So in this way we could take the help of the graph to find the domain, range, continuity, and differentiability of the function, to check all these things. Thanks for watching.